Business Industrial Network proudly presents the Rotating Equipment and Alignment Practices Training Software Tour. In this tour of the CBT Alignment Practice and Alignment Tool, the basics of alignment, accessories involved, and the various methods of alignment practiced in industries will be described. In the full version of this package, there are many animations and diagrams used to help explain various topics. In addition to animations and diagrams, there are several interactive simulations, like the one shown here. Included in the Alignment Practice and Alignment Tool package are several skill tests and evaluations to help further your understanding of each topic. The exact procedure for each method is broken down into easy-to-remember steps. In the functional package, you would be able to place your mouse over each step for more detailed information. Methods such as the rim and face method, straight edge method, and laser alignment are all explained in detail. The exclusive tool Slide Align 2004 is provided with a help content to guide the user in understanding the tool and using it. We shall go through the help content towards understanding this tool. The alignment tool, Slide Align 2004, has been developed to carry out easy and effective alignment of equipments using the popular reverse peripheral alignment method. Slide Align is unique in its ability to suggest accurate corrections as well as educate the user with the alignment basics. The equipment number and name can be entered for reference. The maximum misalignment allowed is set to 0.05 millimeters, and hot alignment compensation is set at 0 millimeters. If required, the user can enter the desired values. The values A, B, and C with respect to the equipment which is to be adjusted is to be entered here. Let us take an example where A equals 60, B equals 120, C equals 220. After entering the values, confirm the entry by clicking this button. On clicking, the graduation lines adjust itself. Using print scale, a graph sheet can be printed where the graduated scales D1, D2, F1, and F2 are properly positioned on the A, B, and C values entered. Towards vertical alignment, the values obtained using dial gauge are to be entered in appropriate columns. Text boxes can be availed sequentially using tab keys or on mouse click. The user is helped throughout by appropriate graphical depictions of the positions at which the readings are to be entered. Let us look into the above set of readings which have been entered. It should be noted that an incorrect set of readings will give an error indication. However, a tolerance of 0.1 millimeters has been accommodated. Now the vertical alignment button is clicked. As seen, a line is drawn on the graph sheet based on the values entered. The values D1 and D2 are obtained by dividing the TIR values by 2. The value F1 and F2 is calculated as well as can be found out in the graph. Depending on the sign of the readings, the solution suggests the amount of shims to be added or removed at the foot F1 and F2 respectively. Let us look at a new set of readings. On clicking vertical alignment, a new graph and values are obtained. As seen, this set of readings suggests to add shims at F1 and remove shims at F2. Another detail is the show quality feature, where the graph line is extended to the maximum proportional scale, along with the relative indication of the maximum misalignment allowed. As seen, if we avail show quality, the line scales to the maximum limit and proportional bandwidth of maximum misalignment allowed is shown. This is useful for comparative evaluation. After corrections are done, the readings can be taken again and the process can be repeated, or the vertical alignment over button is clicked and we proceed for horizontal alignment. The final set of readings obtained towards vertical alignment is transferred to carry out the horizontal alignment. A new set of readings can be entered where the same set of readings can be used and the button horizontal alignment is clicked. As seen, the relative graph and corrections are obtained. D1 and D2 values are calculated by representing the readings differently and then dividing the TIR by 2. This different representation of the readings can be viewed on availing show quality. Depending on the sign of the values obtained, the solution suggests the direction and amount the motor has to be shifted at foot F1 and F2 relative to the view as seen from the top. The tool can be reset using the reset option at any time, and the alignment can be carried out all over again. Using print scale, a graph sheet can be printed where the graduated scales D1, D2, F1, and F2 are properly positioned based on the A, B, and C values entered. Using print page, the current page in the alignment tool can be printed. Thus, Slide Align 2004 proves to be an easy and accurate tool to effectively understand and carry out your alignment needs. For more information on this computer-based training solution, and for other computer-based training solutions, please visit www.bin95.com/cbt.htm.